Hopefully this won't be too alarming. It's compiling. Okay. So what you are seeing probably looks familiar to most people that know Exploding Rabbit. We currently have one game, and it's Super Mario Bros. Crossover. So you see I'm playing the game, it's running, but there's something very different. Well, for one thing, I'm walking backwards. That's a different thing. But now there's something really different about what you're seeing here. Super Mario Bros. Crossover is a Flash game, but this is not. This is actually running in HTML5. And the rendering is done with WebGL, which is a cool graphics technology that runs in the browser. So I don't know if people even understand what HTML5 is or what Flash is, but if you don't understand, I'll explain what it is before I explain why this exists. So Flash is, I don't know if it's technically a virtual machine, or no, sorry, it's a plugin. Flash is a plugin that runs in the browser, so it's like a separate thing. And it's also just like a closed platform owned by Adobe. And HTML5 it runs in the browser like natively, so there's no plugins. You don't need anything special. It basically runs on everything that has a browser because all of the HTML5 specifications are standardized. So what you're seeing here, it'll run on basically everything. WebGL is really new, and it's actually not running on everything yet, but probably Apple is releasing WebGL in their browsers, so like iPad and iPhone will have that in a few months. So I think once Apple releases their new browser with WebGL support, then pretty much all the major browsers are supported. But anyway, so just to show you that this is actually JavaScript. This is the JavaScript file that runs the whole game. So cool. It's not Flash anymore. You can see it kind of plays all right. There's still a lot of stuff that's not working. Especially most of the color changing stuff isn't working. You can see if I change characters, they look really weird because we're still working on, whoops, now I'm in the ground. We're still working on the rendering stuff. I'll talk a little bit more about that later. Oh yeah, I haven't really even looked at the other characters besides Mario. But anyway, so that's what it is. So Super Mario Bros. Crossover is running in HTML5 now. Well, it's in the process of being ported. So how did this happen? Actually, when I announced that we were putting Super Action Squad on hold, a few people told me about a thing called OpenFL. I guess I'll go there. Oh, sorry, I still have the debugger open in the browser. But this is OpenFL. It's basically it's like the Flash it makes it possible. It's not easy, and it still takes forever, but it's possible to port Flash projects to HTML5 or these other platforms. But the only platform that I'm interested in is HTML5. There's other platforms supported, but supporting multiple platforms, even it's still hard to do multiple platforms. So HTML5 is the only one that's in JavaScript. So that's what I'm supporting. So once I found out about OpenFL, I didn't realize what it meant right away, because I said that we weren't going to work on Super Mario Brothers crossover anymore, and we were kind of experimenting with some other stuff. But yeah, like I think it was like maybe a month and a half ago, I just realized why don't Super Action Squad is like it would run on a more advanced version of the Super Mario crossover engine. So when you saw Super Mario crossover running in the browser, and remember the browser can run on like every platform, just because Super Mario Brothers crossover is the game I'm porting, think of it more like it's a platformer engine that I'm porting. So it's a lot easier to like make a game from an existing engine, because the problem that we had with Super Action Squad is that, well, I've kind of said it was just the scope was bigger than I realized, and there's a lot of stuff. Like, we were trying to use Unity, and I don't know, Unity just didn't turn out to be what I thought it was, at least for 2D development. Still think it's a great tool, but I prefer to have more control. And with WebGL, we have like direct control of all of the rendering, which is what we didn't have in Unity. We couldn't use the shaders like that we wanted to kind of give the shaders the data that we wanted to, because Jesse knows a lot about rendering and he's really passionate about it. So with WebGL, we're able to experiment with a lot of cool graphic stuff, even though all you're seeing right now is pixel art. Even though it's pixel art, you can still do some pretty interesting things with shaders. So we have this platformer engine running in HTML5, and so we're using like the same tools. How can I say this? When you make a game, the best way to do it is to make tools for yourself to making the game easier. So we're building some tools to make Super Mario Brothers crossover run, and those same tools will be used to make Super Action Squad run. Specifically, the tool we're working on now is a palette editor. I'm not going to show you the tool for two reasons. One, I'm running a beta version of OS 10, and I don't think I'm allowed to show you Xcode. And the other is that the UI wasn't really our focus. I was just doing functionality. But the graphics you saw there were created with our palette editor program. Let's see here. I'm going to show you what the hell. Sorry. I'm going to show you a nightmare for me. Oops. Okay. Look at this and tell me if you understand it or if it looks like intuitive at all to you. A lot of stuff in Super Mario Crossover changes colors. It flashes up here at the top. These are the flashing pellets. It's hard to see because it's on a black background. I think if I open it in Photoshop, it'll be a bit more clear. Okay. So this is like how stuff in Super Mario Crossover in the Flash version changes colors. I don't even know if it's worth trying to explain this, but it sucks working with it because when I designed this, I didn't know very much about data, I guess. And also Flash itself. The only way to change colors is to do it directly on the image. So if Mario gets firepower, basically the game goes through every pixel on Mario and just like changes them one by one. And with WebGL and with shaders, I'm not very good at explaining this stuff because I don't know the terminology very well. But there's these things called shaders that control how stuff looks, and it's programmable. So you can program like effects for how things look. So I don't have to use this nightmare, like just crazy, horrible color changing system that changes things one pixel at a time. Okay, with WebGL, it's like the pixels are just displayed how you tell them to be displayed. So it's way more efficient, way easier to manage. And so we're building a tool to put the textures and the palettes into the format that we need, and it will make everything. It's already partially working. Like you saw, the game does look like a game that's running on WebGL, and so I used OpenFL. By the way, I'm sorry that this is so technical. I know a lot of people that usually watch my videos probably aren't even. I don't know how technical you guys are, but I've just been immersed in this stuff, and I don't know. I guess it's just nice to tell people about it. Damn it. I forgot what I was talking about. We're making a tool to make changing colors easy. And the same tool can be used on other stuff. So basically like a palette editor for for pixel art. Sorry. So we plan on making a lot of pixel art games. So Super Mario Bros. Crossover is basically operating as a guinea pig for our tools and our future plans. And it also helps that game to survive, I guess, because it's not. A lot of people see Flash as a dying technology. Now it's running on modern, like really modern technology. HTML5 is really new, and WebGL is so new it's not even fully supported yet. I don't really know what else to say about these palettes. We're fixing a lot of. I think I was trying to say before, just like when I originally made Super Mario Bros. Crossover, it's like my knowledge accumulated over time. So like when I started the project, I didn't know anything. And then as time went on, I just kept learning more and more. So stuff I worked on at the beginning is really obsolete. And then stuff I worked on later in the game is less obsolete because it makes more sense because I had more knowledge to write the code better, design the code better, and now I'm designing data models, I guess is what they're called. Let me show you some data now. Learn about some data. One thing I always kind of wanted to do with Super Mario Crossover was make tutorials about, I don't know, just how the game works, because when I didn't know how games work, I would have found it interesting. So, I mean, it's been so long. I've wanted to make tutorials for so long. I guess that's sort of what I'm doing now. Okay, so remember the game, like I said, it was a Flash game. So all of the assets were made in, well, they weren't made in Flash. I mean, they're all bitmap graphics, but like the animations were set up in Flash. Where's Mario? I'll just do a search. Here we go. Okay. Oh yeah, you probably, people that make skins for the game, like, you know, the game is skinnable. They've seen these sprite sheets before. But I don't think anyone's ever seen how, like, the animations are actually done. Okay, here we go. So, this green rectangle is a mask. I think some people probably know what masks are. So, like, anything that's in the rectangle becomes visible. Anything that's not in the rectangle becomes invisible. So, okay, cool, that worked. Okay, so see, that's what it does. The rectangle masks the part of the image that you need to see. That's how the animations are done. And turn that off. So this is Flash. I mean, that's what I'm showing you. The point is this is the Flash program. So I had to get the data out of Flash and, you know, make it usable in the HTML5 version. So I'll show you. So this is like, it's visual, you know, like the actual process of making this stuff isn't really that efficient, and we'd also like to make a tool for making animating sprites a bit faster. So maybe we'll expand our palette editor to be able to do animations eventually. But anyway, that probably wouldn't be for a while. But anyway, so in the Flash version, like this data is just sent directly to the game because it's Flash, so it's like compatible. I'm going to tell you, okay, there's this thing called JSON. I'll show it to you. Let's see. I'll just do, okay, so look on the left here. Oh, that's not even the right file. Sorry. This is a really big file. If you look on the left, this is all the data. It's probably kind of hard to read. This is what JSON looks like. It's just like, it stands for JavaScript Object Notation, and it has objects and arrays. So this is what the raw JSON looks like. Now let me show you. I have an editor that it just makes it a little bit easier to manage it. So on the left, you can see the actual JSON, and on the right is how you can interact with it in a hierarchical way. Let's see, let's find Mario. Okay, whatever. Okay, here's Mario. So the data that you saw in Flash is all here. I mean, data, like there's a lot of different ways to represent data. So like what you saw in Flash was a visual representation of what you're seeing here. So I just I exported the raw data into a format that I thought made sense. So hit rectangle IDs, these are like his hit boxes for his collisions. Oh, I didn't show you that. Let me show you that really quick. He's kind of okay. So see this red box? That's his collider, his hit box. So it mostly stays the same, but you'll see. Okay, see when he's bigger, it's taller. So that just tells the game like if anything is touching inside this box, he's hitting something. So this tells it what texture to use. These are the actual frames. Mario has 2 objects in every frame because the Game Boy version of him can actually have a feather. Like when he gets firepower in Game Boy, he has a feather. So there's 2 objects in every frame. And every object has... So in WebGL, they're texture coordinates, or also known as UVs. But it's that mask, that rectangle you saw. So this is the actual like data for that rectangle. And then like that, whenever Mario switches to a new frame, like if he's walking, it sends different texture coordinates to the shaders in WebGL, and then it draws those texture coordinates. So that's how it animates. This was like my first time working with, I don't know what it's called, the GPU. OpenGL. It's really similar to OpenGL. Sorry, I don't know the terminology for this stuff. I just know how to use it. I don't know. This is probably getting kind of long. I guess it's just this stuff it's interesting. I didn't think it would be so interesting porting a game from Flash to... Oh, let me show you one other thing. So OpenFL, well, let me start with Flash. Flash is written in a language called ActionScript. Let's see if I can find Mario's... What program is this going to open? Okay, whatever. So it's opening in Flash. This is... Whoa, it's really big. This is ActionScript. This is what the game was originally written in. Here's a function. That's what it looks like. And then the language I'm using now is called Haxe. Haxe. And it's really similar to ActionScript, but it's actually a little bit more powerful. It has support for generics, which is very nice. Something I had no idea I was missing back when I was making the original game in Flash. But the cool thing is though that the languages actually look really similar and have a lot of the same features and they work the same way. This is why it was possible to port the game. Super Mario Crossover is really, really, really big. Let's see if I can show you this is probably my biggest class. It's called Level. It's back when I first wrote the game, I didn't know a lot about what's that called? Just where you separate, you kind of modular. You make it more modular, so you kind of assign different tasks to different classes. But I didn't really understand that concept, so a lot of the stuff is in this one class. So this is just a really long I don't think I have the line numbers. Well, apparently I'm on line 3742. Okay, so this class is 3742 lines. This is just one class, and there's hundreds of them. And this is probably the biggest one, but there's a lot of other big ones. So the porting process took a lot of patience. I'll just say that. And I'm not done yet. Like there's still a lot of bugs that need to be fixed. And I don't know if the first release of the game, or I don't even know if I'll put in all of the features that are in the Flash version. Some of the features I just don't think are really, I don't know, I mean, the game's been worked on a lot, and some of the features I think are kind of obsolete. So I might not even have everything in this version. So it's been a crazy time. Just thought I'd show you a little bit of this is what I've personally been working on, and Jesse's working on the tool. I'm the one with the most time, so it makes sense for me to be working on this, and Jesse's making tools to making this game and other pixel art games to make it as efficient as possible. So that's kind of what we've been up to. I guess there's one other quick little, let's see, these are, when you see this, see how this is gray? That's because the color data is actually stored somewhere else. So these gray values are sent to the shader, and then it also sends the colors separately. And then it uses these gray values to know where to get its color. So like, you saw that had different shades of gray. This is, damn it, it's really small. So this is just a palette palettes for the Nintendo skin, the default skin for the game. So with those grayscale values, it knows where to look in here and what color to use. And if you just give it a different row, like you could send it the first row, or you could send it the second row, third row, whatever. That's how stuff changes colors now. It's way, way easier. It's no longer just changing pixel by pixel. It just looks in the right place. So that's how color changing is done now. Sorry, I keep opening the wrong thing. Okay, look at this file. This file. So this is called the theme sheet. The theme sprite sheet, basically. You can see that like there's a lot of data that's redundant. So like, just like look at this ground. It's like everywhere. And why was it designed this way? I guess I'll show you the Super Nintendo one. So it's because some of the skins have, like, they need the extra data. See, like all the ground, it looks different. It's different kinds of ground. But even this, this has duplicate data too. Look at all these blocks. So I just thought that was kind of really wasteful. So, okay, so see this, and then look at this. This is all the same. This is all the data that's needed. Instead of that gigantic sheet, I can actually, these are all of the graphics. I mean, hopefully I didn't miss any. I haven't actually checked. I haven't started using this yet, but These are all the pixels I need. It's everything's 16 by 16. So basically, whenever it shows any of these things, I just have to give it the correct texture coordinates, the UVs, so that it'll show the right one. I mean, so I don't need all that duplicate data. I have the texture coordinates stored in a JSON file. So that's what I said. I'm using JSON a lot more, and since the game runs in JavaScript, I assume that JSON runs. It probably parses it really fast. It's also really small. It's also just a good way to visualize data. I really like data. Never knew I'd like data so much.